All right, so in this video, we're going to continue talking about functions. I'm going to get on Replit and we're going to program some examples of functions. So there are a few things that we talked about in the video yesterday that I would like to reiterate. One, just kind of a reminder for what a function is. A function is going to be a set of instructions. It could be one line, it could be multiple lines, it doesn't really matter. We are going to create it with the reserved word def for define. And we're going to give it a function name. And then anytime I want the program to go do those things, to go follow those instructions, I'm just going to call the function by name. And I can call the function as many times as I want. So even though I only write that chunk of code one single time, I can use it over and over again repeatedly. So let's start with a really simple one. We're just going to say define greeting. And functions are going to have parentheses. You might have something in the parentheses if you want to pass information into the function, but you don't have to. Not all functions need information passed into them. So here, I don't need any information passed in because this function is just going to do the same thing all of the time, no matter what. It's just going to print hello. And that's it. That's going to be our greeting. So then down here inside my program, and when I say that, this is all my program, so maybe that was a poor choice of words. Down here outside of the function, and you can tell I'm outside of the function because I'm no longer indented. So down here in sort of the main body of my program, if I wanted it to print hello, I could just call greeting. So I could say greeting. And did you notice that the computer kind of pulled that up for me already? They were like, hey, it looks like you might be typing this in. I recognize it as a command. I know that this is something that is part of this code. Look, it even became color coded because it's like, look, this is a command. I recognize it. I see that this is something that the programmer has created as a function. And so now when the computer gets down here to line 4 and I call greeting, it says, oh, I know what to do. I come up here and I find, where have you defined what you want me to do anytime greeting is called? Well, I want you to print hello. So we can run this. We get our output that we expected. Fantastic. We're going to improve on this a little bit now, and we are going to make our greeting a little more personalized by passing in a name. If I want information to go into the function, it goes inside the parentheses. And now when I'm here inside the function, if I use the variable name, the computer is going to recognize that I want it to insert in whatever value was passed in inside the parentheses when the function was called. That's an input parameter. Okay, so here we're going to say hello, name, and exclamation mark. And then I think it might actually give me an error if I try to run it again now. Yes, it does. Okay, fantastic. So this is one of the things that I want to point out in this video. A lot of the questions in quiz 4 and the questions on exam 2 that have to do with functions are asking you about valid function calls. What are the things that you need to know? What are the rules to be able to actually use the functions that you have created? So here's one of the rules. My input parameters have to match. If I told the computer that whenever I call greeting, I will pass in some input that I'm going to be called name. Then down here on line 4, when I call greeting, I have to actually give it a name. And if I don't, I get this error. And look, it's actually a pretty good error message. It's pretty descriptive. It says you called the function greeting, but you did not give me an argument for name, right? I expected some input. You did not give me the input. That is an improper function call. So now if I change it and I include having Micah there, now it does insert it in here. It says, hello, Micah. Fantastic. I guess we don't need that blank space because it inserted it in there for us. Okay, wonderful. And so we talked a little bit about how, you know, the idea behind this is that you can have your instructions and then use it repeatedly. I could use this same greeting to say hello to lots of people. I could say hello to my husband. I could say hello to my oldest son. I could say hello to my dog. Sure. So if we look at this example, I'm using the same command. I keep using the same function call. I can write greeting over and over as many times as I want. But whatever I pass into it as the name is the value that it is going to print as the name here in my print statement. So even though it's the same command, it can give me different results. I can have a different output based on the input that I gave it. In the slides yesterday, we talked about a fruitful command versus a void command. And that can be really tricky for people to kind of understand the difference. And what was confusing about it to me whenever I first learned about this stuff is that if an answer was printed to the screen, then in my mind, you know, it did something. And so, you know, you might think like, well, all functions do something, right? We have some sort of output. We see some sort of result. Printing something to the console is not the same as calculating a result and then returning it back to the program, back to wherever the function was called. Those are two different things. So this would not be really like a fruitful function because I did not return anything. Even though there was some output like printed to the screen, it's really just kind of following my instructions. It didn't calculate the result of anything and it did not return the result of anything. So let's take a look at an example of a function that is going to be a fruitful function and it's going to pass back an answer. So I'm going to do one that will just add up two numbers and that's it. So I am going to define a function. I will call it sum because I'm adding up numbers, right? So that makes sense to me. So I'm going to call my numbers X and Y. And what I want this to do is return. Notice how that changed colors. Return is a reserved word. That is a special word. The computer knows it has special meaning. I am saying, I want you to take this result. It's going to calculate, you know, the answer to whatever I ask it to do over here. Take that result and return it back to whatever line of code you called it in your program. Wherever the function was called, take this result and send the answer back there. So let's take a look at the answer at an example of that. So if I passed it in two numbers and I asked it to return X plus Y. Down here, I could say, I am going to use the total function and I'm going to take the answer and I'm going to store it in a variable. That's going to be the first example I do. So total is going to be my variable name. Total equals sum of 3 and 4. Okay. So what's going on here? What is the computer going to do whenever I run this program? So these are just defining functions. It's there, but we're not going to execute them yet. Okay, here we go. This is the first line of code where I really ask the computer, go ahead, run this. So what is it going to do? It's going to follow the instructions for sum. Well, here are the instructions for sum. Sum says you needed to pass me in 2 pieces of information. And down here where I called the function, I did pass in 2 pieces of information. So then the instructions say add those 2 numbers together. Okay, in this case, 3 plus 4 is 7. So right now my answer is 7. Return that answer back to wherever the function was called. So this whole entire thing is basically just going to become a 7. Okay. For this example, if we had given it different numbers, obviously it would be, the sum of whatever numbers we passed it in. So this whole thing is going to equal 7. 7 will get stored inside the variable total. So we could print total and we could have the number 7. And we could use that, because we have this defined, we could use our sum function for as many different numbers as we wanted. As long we could pass in different values here. So like what would be like 9 plus 4, and it's going to follow the same instructions. Add the numbers together and pass the result back, but my output could be different because I can give it different input. Okay, so that's one thing to make sure you know about a valid function call is that your arguments that you pass in when you actually call the function need to match the parameters that you defined it would have up here whenever you created your function, right? So here I told it I would give it 2 pieces of information. If I only give it 1 piece of information, that's not correct. That's not what it asked for. And so I get an error. Okay. But as long as I give it the 2, it's happy. It can follow the instructions that way. The second thing to know about the valid function calls is that when you have the word return, when you are a fruitful function and you return something back, you are a fruitful function. If you have that reserved word return, then you want to do something with the result that gets passed back out to it. So you want to store that in a variable, like the example that I have here. You could print the result down here in the main body of your program if you wanted to, or something we talked about in the slides is you might want to use the result of this in another math statement. You might use it in another expression. So let's take a look at an example of that. So let's say we're going to find the average. And so the average of these 2 numbers would be equal to the sum. So let's find the average of 4 and 6. So that would be really easy. The average of 4 and 6 should be 5. That would be right in between them, right? So if I say take the sum of 4 and 6 and then divide it by 2, right? So my average would be the result of add these numbers up and then divide it by the total, right? And then if I wanted to know what the answer was, I could just print out the result. Beautiful. I do think it makes sense for it to have a decimal because most of the time an average would not be a normal whole number. If we wanted to force it to be a whole number, we could do integer division here. And in this case, 10 divided by 2 is 5 evenly, so it wouldn't have made any difference. But if that had been, like 11 divided by 2, then our answer would be changed because it would chop the decimal part off. So that's just kind of a little reminder to you guys about the difference between integer division and just regular division. Okay. So we have examples here of creating a function. We have examples here of some function calls. We did a function call with multiple different input variables. We did some where we stored it in a variable. We did one where we did some math with it. You can, what's another example I might want you to do? Return statement, matching parameters, different input variables. Oh, okay, so this will be our last example. We are going to write a function that will call another function. So here, I'm just going to do the same thing for average that we did down here, and I'm going to turn that into its own function. So then we could use it and find the average between as many different numbers as we wanted to. So one thing that I'm going to be careful of is that if I am going to create a function called average, and I know that I want average to use the function sum. So we're going to write a function that will call another function. I need to make sure that sum was defined first. Okay, the computer isn't going to know what you want it to do when you use the word sum if you haven't defined it yet. So make sure that sum is up above where you create average. Okay. Okay, so we're going to call average with two numbers. And the way we are going to find that, and I want the answer to be passed back, so we'll call it return. We'll use that reserved word return to say find your answer and pass it back. And we are going to find the sum of whatever two numbers they pass into us. And then we are going to divide it by 2. So now we have this defined. These are the steps to find the average between two numbers. Add them up, divide by 2. Do that every time. So now that we have that, I can just say average, and then I could do, whatever, 3 and 5. It doesn't really make a difference. And you see how that kind of like became a reserved word now. It changed the color of it because average is now a command. It's one that I made. And the computer knows anytime I use the word average, that means come up here to line 7 where I have defined what that is. Find the sum of the two numbers, divide by 2. And it doesn't have to be two numbers. We could have given it as many different input parameters as we want. So let's go ahead and throw a Z in there. If I were going to add up 3 numbers, then I would divide by 3. And then up here in my sum, I would have to give it 3 numbers as well. So we would just add up all 3 of them, and that would be fine. So if I wanted to find the average of 3 numbers, that's cool. Add up all 3 numbers and then divide by 3. So now I could say, like, what's the average between 5, 10, and 15? The average would be the middle number, right? So it should be a 10. Uh-oh, what have I done? So I have XYZ, missing the Z. Oh, because I had an example up here on line 10, right? So because I changed sum, remember a valid function call, the number of input parameters have to match. Because I changed sum up here to be 3 numbers, I would have to have 3 numbers down here. So let's make that, sure, why not? I kind of forgot about that other example that I had up there. So the average of 5, 10, and 15 would be the middle number. It's 10. You don't have to store the result in an input variable like that. We could have just directly printed it. So like here I said, do this math, save the answer, print out whatever is stored in the variable that has my answer. I could have just directly said, print what is the average between 10, 20, and 30. And so that should just print out our middle term, which is 20. Beautiful. That is everything for functions. I think we've had some good examples of multiple different ones. And so quiz 4 is over functions. And when you take it, it's going to ask some different like valid function calls. And you want to pay attention to your input parameters, and you want to pay attention to whether or not it has the word return. Okay. If it does have the word return, make sure that you're kind of doing something with your function call. If it does not have the word return, like up here where we said greeting, if it does not have the function return, then we can just call the function by itself, right? So that was like that first example I did where I could just call greeting. I don't have something that says like print greeting. I don't need to. The print statement is up here in the instructions, right? We could just call the function. I didn't need something that said like name equals greeting. In fact, let me show you that because that wouldn't make any sense. So if I said, you know, like name equals greeting Micah, it would run. It's like valid in the sense that it'll give you output, but this really does not make sense. Like this would not be the most appropriate function call because this does not return anything. So there's nothing for me to store inside of name. In fact, in most languages, this would not even be allowed. This would give you an error. Python will let you do it, but you shouldn't because it doesn't make any sense to do that. If I'm not, if I'm not returning anything up here in the function, then it does not make sense for me to put that function call inside of a print statement or, assign the results to a variable or something like that because there's nothing for me to save. We can just call the function like that. If you feel comfortable with those concepts, then I would say you're ready. You can go ahead and take it. It is going to ask you to write your own function. It's a really simple one, like these little examples, it'll only be like just 2 lines like that. You'll have the heading and you'll have 1 line of code, but just be prepared for it. I would recommend getting on Replit and just trying to write some yourself, maybe some of the really simple things that we have talked about, including from last week, like try to write a function that could tell if a number was even, or try to write a function that could tell if a number was positive, or try to write a function that could tell if a number was greater than 100 or something like that. Just kind of give some very simple little practice. And if you struggle with those exercises, for sure, email me or come to one of the Zoom meetings. We can do those, we can write those together and do some examples until you feel a little bit more comfortable with it. That is the very end of all of Python, and that's all of the programming that we will do in this class. I love programming. I think it's a really fantastic tool. There are a lot of neat things that you can do with it. And Python is a beautiful, simple language. If it's something that you're interested in maybe learning more about or kind of seeing some of the different things you can create with it, you might be interested in signing up for a CS1 course and seeing if programming might be something that is for you. So we will tomorrow we will be preparing for exam 2, which we take Thursday. So tomorrow is the big day we will take the test, and I will have a review video for you to watch. See you then.